Hey guys, happy Tuesday. Sorry I'm not in class with you, but this presentation will walk you through the notes and then get you ready for your assignment today. So here we go. Friendly reminder that your water cycle lab is due tonight. It should be submitted on Canvas as a PDF, and so make sure you get that turned in on time because you really don't want a late grade for your first lab assignment. These were some reminders about the conclusion questions. I'm pretty sure that I went over all of this in class on Friday. The big things are highlighted to make sure before you turn it in that your Part A has actual data in it. So that's where you actually have to use numbers from your lab and milliliters or percentages of humidity. And then whenever it says explain your reasoning, you need to explain your reasoning. Part C is a big part of your grade if you look at the rubric, and it's important that you tell me why you say what you say. That's going to help get you some more points. Okay, so right now I need you to have your notes packets out. I'll give you a second to get those out. I handed them out on the first day of school. If you didn't get one or you lost it or whatever the case might be, please go up to the front of the room by the student stuff. There's still a large stack there, and you're welcome to get yourself another packet. So on page 4 is where we're going to start. This week we're going to be looking at water. So we're going to start with what's called surface water, so where the water is on the surface. This is a lot easier for us to understand because we can see surface water. When we get to groundwater later in the week, that's when things get a little bit tricky. So you're on page 4 of your notes packets, and the first thing we're going to start with is kind of the most important part, which is water called runoff. So runoff occurs when water flows over the ground instead of sinking into the ground. So we have a lot of runoff here, so this is a very easy thing for you guys to understand. It just rained a few days ago and we saw water becoming runoff all over campus. On page 4, we're going to list the 4 factors that affect how much runoff a place will have. So number 1, on that chart right there where it says factor, in the number 1 box you're going to write soil composition. So soil composition is the first factor. The description of soil composition is this. Soil composition is the particle size that makes up soil and helps determine the pore space of the soil, the pore space. Later this week, we're going to do an activity on pore spaces or porosity. And the ability of material to absorb or reject water is highly determined by how much space is in between grains. So if you look at the picture at the bottom here, these large grain sizes have quite a bit of space in between each other. Tiny grain sizes, something like sand, they have a little bit of space in between each other. The best, or I should say, the combination of the two, both big and small, this stuff has almost no pore space. There's almost no air in between those grains. This scenario over here, the one on the end, that is exactly why we get a ton of runoff here at school. If you ever pick up a big handful of this material, of this sediment, you're going to have a handful of soil, or not soil, you're going to have sand and gravel, and it fits really tightly together. And so the water can't get through. So the water can't penetrate through the sand. It can't go through it into the ground, so it starts to build up right away. As soon as it starts raining, we start to get puddles all over campus. So the sketch that I made that looks horrible, because I drew it on my laptop with my trackpad here, is showing large sediments that have a lot of pore space in between them. So you should have, for number 1, your factor is pore space, your description is the space in between sediments, and your sketch is just a picture of this. It's just rocks with pointing to pore space. Your number 2 factor is the rate of precipitation. So again, we're talking about things that affect how much runoff is going to be in an area. Obviously, if it's raining really slow, the ground can absorb it really slow and be okay. If it starts to rain really fast, if the speed of the rain exceeds the speed of infiltration, then it will become runoff. So this right here is your description. If precipitation exceeds infiltration, the water will become runoff. If precipitation exceeds infiltration, the water will become runoff. I couldn't really think of an easy way to sketch this, so literally what I wrote in my sketch box was this: faster rain equals more runoff, which is pretty much what you wrote in your description. So that's a little bit ridiculous, but I couldn't think of anything. I used to draw something really cool in class, but I'm not in class to draw it, so sorry, you're missing out. If this video is going too fast, you know that all the notes are on Canvas, so you have two ways of getting these notes. Here's another picture that's kind of cool, that's just showing how slower rain is going to be able to be absorbed, faster rain is going to drain and become runoff somewhere. Number 3, so on page 4, number 3, that factor is vegetation. Vegetation is the same thing as plants. That just means plants, if you aren't familiar with that term. So having more vegetation slows runoff. This should make sense. If rain is happening in a place that has a whole lot of plants, those plants, the roots of those plants will be able to absorb the water. And it will decrease the amount of water that becomes runoff. So remember, runoff is how much water stays on the surface. So if there's a lot of plants around, they're all going to absorb it. It's going to get stuck to the leaves, it's going to get stuck to the trunks of the trees, it's going to go into the ground, and the roots are going to suck it up, especially if there's been a long period of drought. So the number 3 factor is vegetation. The description is vegetation slows runoff. I don't have a personally made sketch here. Gee, I thought I did. So this picture is just showing how having plants available is going to slow the movement of runoff. So you could draw a much simpler version of this, or you could kind of just draw here what I put in the circle. So, or just make a note for yourself. Lots of plants, slow runoff. Because all of these plants along this hill here, the trees are going to absorb the water, the leaves are going to absorb the water, the roots are going to absorb the water. There's a ton of little sponges over here that is going to absorb the water, preventing it from becoming runoff. Factor number 4 is slope. So somewhere like our campus, it's really flat, and therefore the water accumulates. So number 4 is slope. And here's your description. This is your description right here. The steeper the slope, the faster the water flows. This is pretty obvious. I don't think I have to explain this one to you. Somewhere that is flat, like Arizona, or at least southern Arizona, it has the ability to absorb more water faster because it's flat. If water hits the side of a mountain, it's really hard for that water to be absorbed, because as soon as that rainwater hits the ground, it's going to start rolling. It's going to go down the side of the mountain. So the 4th factor that affects how much runoff an area will get is slope. The steeper the slope, the faster the water flows. That's the description for that box on page 4. So this is, you could just draw something simple like this for your picture. All the water is flowing down slope. So as the rain is hitting the side of this mountain here, it's just running down. This is kind of a combo of number 3 and number 4. So over here it's showing a steep slope that has vegetation, which means it's reducing how much water goes down the hill. This is directly related to the mudslides that we talked about last week. So last week there were all those mudslides in California. And I told you that the biggest reason that those mudslides were happening, it wasn't the amount of water. You can have a ton of water, and if you have a lot of plants, then it doesn't matter how much water is raining because the water is gonna, because the plants are gonna absorb it. But in the case of California, what's happening is over here on the left. They had forest fires, which demolished the plants, and there's a lot of areas that are very mountainous in California, and therefore they have a lot of mudslides happening. It used to look like over here, but now it looks like over here. When you're done drawing your picture for slope, go ahead and turn your note packet to page 5. So this is kind of going in chronological order. So we have runoff. Runoff has accumulated somewhere, and now we're going to get to what happens with that runoff. So runoff is then going to join what's called a stream system. Even when it rains at Boulder Creek, that water that becomes runoff will either slowly get absorbed by the ground, or it will slowly roll into a wash and join the stream system. This has some surface water flows in thin sheets and eventually collects in what are called channels, which are areas where streams flow. So there's all sorts of different channels, but the runoff will flow until it hits a channel. The first thing it's going to form is what's called a tributary. So rivers that flow into other streams are called tributaries. So this is a cool picture that shows 1s, 2s, 3s, and 4s. The 1s are little tiny channels, and those combine into the number 2s, and then a bunch of number 2s combine into a number 3, and then a number 3 combines into a number 4. So the 4s are where all the water accumulates. So 1s goes into 2s, 2s goes into 3s, 3s go into 4. And those are all, this is creating a tributary system. So here's another picture showing how the small streams are going into slightly larger streams, and then they're in the mother lode of a river over here. This is a picture, I think I took these last year, where we got a lot of rain really, really fast on campus, and you could actually see this sort of process of the water finding its way. Like these two channels here had rolled off the sidewalk and then formed a channel here in the gravel. Because we have so much gravel around campus, it's really neat to see how it works its way down into the wash or into the quote-unquote Boulder Creek. So these areas of water then become what's called a watershed. So all of the land area that drains into a stream system is called a watershed. So in this picture, this is all the watershed for our portion of the Colorado River. So anywhere in this region of our country that it rains, the water will eventually get to the Colorado River. If it doesn't get sucked up into any of our drinking water systems, if it doesn't go into any of the SRP canals, but anything that falls on the ground that becomes runoff will eventually join the Colorado River. Now the areas between watersheds are a divide. So divides separate different watersheds. So obviously if it rains in Ohio, that runoff isn't going to join the Colorado River. There's a different watershed for that. So I remember that as a shed. A shed is a place that holds your landscaping tools. It keeps something. So a watershed is an area that the water is held for that river. So here's an example. If you've ever been to the Continental Divide, this is kind of cool. Maybe your parents made you stop at it. You were driving across the country and you saw the sign. This is the Continental Divide. I know I've stopped at the sign and gotten a picture. The Continental Divide is cool. So everything, all of their runoff on this side of the country will eventually make it to the Pacific Ocean. All of the runoff on this side of the country will eventually make it to the Atlantic Ocean. That is what the Continental Divide is. It's this super high point right there kind of along the Rockies that as you pass it, if you were water, you would then someday make it to the Atlantic or someday make it to the Pacific. It's kind of cool. It's a divide. Here's some other, this is another map that's showing, gosh, I gotta look at it for a second. Oh, these are showing the divides. So this is kind of showing if you're on this or this side, you go to the Atlantic or the Pacific. This is another divide that kind of cuts through Canada that determines whether it's going to go to the Gulf of Mexico or it's going to go to the Hudson Bay. These are all different divides that if you're on either one of the sides, your runoff is going to feed to two different areas. So these regions are called watersheds. These colored lines are called divides. That's a vocabulary, those are two vocabulary terms that people frequently get confused, the difference between a divide and a watershed. So now that we have water that are entering rivers, one of the last things that we're going to do here on our notes is called stream loads. So at the top of that chart, so we're in the middle of page 5 right now. At the top of that chart, it says stream load is the material that a stream carries. So we've talked about this. When we did sedimentary rocks and I ran around the room, sorry, and I ran around the room, so I was a rock that's in a fast-moving river, we know that rivers can carry different size sediments. So across the left-hand side there, you have a column that says method of transport. In the number 1 box, you're going to write the word suspension. And in the box right next to that, here is the description. A suspension load are all particles that are held up by the turbulence of a stream's moving water. So in other words, any rock or log or any item, any piece of sediment that is being moved by the water is called the suspension load of that river. All particles that are held up by the turbulence of a stream's moving water. That's what goes in your description box in the middle of the page on page 5. So here's my sketch. I drew a really lame picture of water, and all the different size particles are all being moved by the speed of that water. This is called the suspension load. Any items that are being moved in the water. Usually this is just sand. So yeah, make sure in your picture that you have particles drawn in water and showing the movement. The second type of suspension or stream load, the second type of stream load is what's called a bed load. You could probably figure out what this means. So number 2, where it says method of transport, you're going to put bed load. And then for this description, you could probably shorten this. It's anything that's being rolled or pushed along the bottom of the stream. So this is, like it says, anything that it's not floating in the water, it's not mixed into the water, it's just slowly being pushed. So that's when we actually get into hydrology, that's an actual field of study, it gets really particular. Whether is the rock rolling, did the rock just get flipped over in the water? It counts as a bed load if anything is moved at all at the bottom of the river. Anything that's being rolled or pushed along the bottom. There's my really awesome picture. So my picture is easy. I just drew some water and then put some rocks and stuff at the bottom. So like I said, even the smallest movement would count it as a bed load. So even if it just so much as this piece rolls over to that piece, I guess I kind of already had an arrow there, that would count as bed load. All right, we're going to finish up page 5 here, and then you'll be done with notes for today. The third type of stream load is called a solution. So number 3 for method of transport is a solution load. You could probably shorten this one too. It's all of the soluble minerals. If you know what that means, great. If you don't, it's just another word for this. Some books call it dissolved load. It's all of the minerals that are already in the water. So we know that mineral has tons, or we know that water has tons of minerals in it, and if you were to, boil the water and evaporate all the water, you'd be left with little pebbles of all sorts of stuff at the bottom of your pan. The solution load is just that. It's those minerals and particles that are dissolved within the river water. So this is a cool diagram that I wish was in your notes packet that shows the bed load at the bottom of the river, stuff that's big and just kind of rolling, the suspension load, which is normally sand and silt that's mixed up into the water, and the dissolved load, which you can't see. I don't care how good your glasses are, you cannot see a dissolved load or a solution load because it's dissolved into the river. My picture for this one is really lame. It's a river. You can't see a dissolved load or a solution load. It's the minerals, it's the salts, it's all the different sediments that have actually been dissolved into the water. I've already alluded to the term called carrying capacity. So carrying capacity is the ability of a stream to transport material. Obviously, this depends on two things: how fast the water is moving and the amount of water. So even if you have a lot of water, if it's not moving very fast, it won't move very much. We're going to do a lab next week where we go outside with the stream tables and we examine this. We can see how much a river can actually move. So carrying capacity is the ability of a stream to transport material. This is more going to get into river. I'm just going to skip this one. Last but not least, floods. I bet you can figure out how to define a flood. A flood occurs when water spills over the sides of streams' banks to the adjacent land. So when a river gets maxed out, when it has a ton of runoff, so all those tributaries and stream systems, and the watershed is filling it up more than it can handle, you're going to end up with a flood. And then, of course, floodplains. Some of you, especially if you live in New River, a lot of folks in New River, your house is actually in a floodplain. That's sometimes not a great thing, especially here, because obviously you're at risk for flooding. So a floodplain is any area that is at risk for excess water during times of flooding. So it's kind of confusing. A flood is just the overflow of a river. A floodplain is the land that's next to the river that could possibly flood. Lots of folks in New River, you live in a floodplain, unfortunately. This is a map that's showing all of the flash flood areas of Phoenix. So to give you some perspective here, if I was in class, we'd spend a little bit more time talking about this map. But for now, notice that here's downtown Phoenix. Okay, here's I-17. Oh, I have a dot. Ha! Here's us. You can see that we are in the red. And the red is, oh, well, what do you know? The red is a high risk for floods. Everyone kind of up in this northern region, we are surrounded. Look at all these stream channels. We are surrounded by regions of what you might call a wash, what I might call a stream channel, areas of water that when we get heavy rains, water comes down from the higher elevations through these channels. So of all the areas in Scottsdale, we live and we work and go to school in one of the most high-risk area for floods, unfortunately. All right, here's what you're going to do. Just like we did on the first day of the semester, you are going to do 2 pages. You're going to do page 3 and page 6 in your notes. Those are 2 worksheet-looking pages. Page 3 is about the world's water supply. It's just kind of some information on where all of our water is. There's 9 questions there. And on page 6, that is about surface water, which is what we just did. So you might need your notes for that one. And there are 9 questions there. This is due by the end of class. So please work on this. You will use ScanBot, and don't forget to click on multi-page before you scan your pages, because multi-page is what allows you to add 2 worksheets to the same file. If you have any troubles doing that, please ask around class and find someone who knows where the multi-page button is. I tried to show it to as many people as I could last week when we were working on that water cycle assignment. That's due today at the end of class. And then obviously don't forget that your water cycle lab is due tonight at 10. If you have any questions, email me. I will actually be in my classroom later this afternoon. I'm only gone this morning for you guys. So if anything gets confusing or whatever, you can come by and talk to me this afternoon. Thanks for paying attention to notes. Be nice to the sub, and I will talk to you later. Have a great day.